Welcome to the first video on a series of 5 about graphing trigonometric functions. This first video is about something I call pi algebra. Pi algebra is not a phrase you'll hear anywhere else, but it's apt given the situation. Here's what pi algebra means to me. Suppose we wanted to work out this math problem. Well, you probably recognize the number pi as having a decimal equivalent of about 3.141529, etc., etc. I'll put a 3 decimal approximation here, not that it really matters. If you were to work this out, you would first do the division in the fraction on the top, 3.142 divided by 4. Then you would subtract, and then you would divide. You may or may not use a calculator, but you could easily do this problem. Here's the issue, though. We have a tradition in algebra not to represent pi as its decimal equivalent. So how then could we simplify this expression without using 3.14 as a replacement value for pi and therefore getting a decimal answer? Well, I like to pretend when I'm doing these problems that the pi is actually the algebra symbol x. That's not really what we're supposed to do here in the sense of pretending that pi could be any number. Pi is a very specific number. But what I'm saying is I'll treat the problem on the top the same way I'll treat the problem on the bottom, just treating the pi as an x. Here's what you would do if you were given this algebra problem that you see in the bottom here. You would probably try to get a common denominator first in the top of your fraction. Here's an important trick. Notice what I've done here. I've replaced x with 4x over 4. These are equivalent expressions, and it also achieves the goal of getting a common denominator in the top half of my bigger fraction. Because now I can combine the two fractions with the minus between them, 4x minus x being 3x, and get a single fraction on top. Then, recalling that dividing by 2 is the same as multiplying by the reciprocal of 2, and then multiplying across, and using some basic algebra here, you can see that the answer, or the simplified version of this, would be 3x over 8. Now, I'm not suggesting that you literally take out the letter pi and replace it with the letter x, but just for a mental thought process, treat pi as if it were a, quote, variable, and just do the simplification as if it were an algebra problem. And in that sense, this expression at the top simplifies to 3 pi over 8. That's what I mean when I say pi algebra. To take an expression with pi in it and rewrite it as a simpler expression using pi, never using the 3.14 value that we typically associate with that symbol. One particular skill that you're going to need for the rest of this video series is to be able to find midpoints on a number line. Here's a number line, here's 2 points. Suppose we knew the numerical values of these and we wanted to know the midpoint. The way you find the midpoint is by taking an average. In other words, you add the two numbers and then divide that result by 2. What if those numbers are multiples of pi? Well, it's the same thing then, of course. If you want the midpoint of those two locations on a number line, you average them. In other words, you add them up and divide by 2. Now, because we're not using 3.14 as a pi approximation, we're going to have to use our pi algebra to simplify this. So I replaced pi with 2 pi over 2 just to get a common denominator in the top. Then I can combine the fractions on the top, combining 2 pi plus 3 pi to get 5 pi, and then remembering that dividing a fraction by 2 is the same as multiplying it by a half, I now have a simplified version of the midpoint of my original 2 points. And that's how you find a midpoint on a number line. And like I said, we'll need that moving forward into the trigonometry graphing videos. But by the way, even though I found the midpoint, I'd like to point out that there are some students out there whose brains are oriented in a special way that they don't have to do the algebra that you just saw. Watch and see if you're such a student. Thinking of this as 1 pi and thinking of this as 1½ pi, it's obvious to some people that the midpoint would be 1¼ pi, which is the same as 5 pi over 4. Now, the typical student doesn't think that way at all, but if you happen to be such a student, you can avoid a lot of ugly algebra and just figure the midpoint in your own clever way. If that made no sense to you, don't worry, you always have the pi algebra to fall back on. Now let's look at a situation where we're shifting to the right or the left on a number line. Suppose I have a number line, and on that number line is pi over 3. And suppose I want to find the point that I would arrive at if I shifted a certain distance, say to the right. What would that point be on the number line? Well, it stands to reason that if you're at a certain point and you're shifting to the right, and you want the new location, that you would add those numbers. So to figure out this new point, I'm going to add my starting point plus the shift. That's fairly clear. Now it's just a matter of working out this algebra problem. So to get a common denominator, I've changed pi over 3 into 2 pi over 6, mathematically equivalent, but now I have a common denominator. Now adding the numerators, 2 pi plus 7 pi is 9 pi, and 9 pi over 6 reduces to 3 pi over 2. So I've now found the shifted point on the number line. Now, it is possible, if you think a certain way, if your brain functions in a certain manner with fractions, it's possible for you to do this without the formal algebra. Not everybody likes it or wants to do this, but you might find this as a shortcut. Watch and see if you think this way. This number here is the equivalent to 1/3 of pi. I'm shifting 7 pi over 6 to the right, which is the same as 1 1/6. So ignoring the pi's temporarily, 1/3 plus 1 1/6 is 1½ and that also would have led me to 3 pi over 2 as the result of the shifting point. Again, if you don't like thinking in fractions like this, then this is not the thing for you. You can always resort to the basic algebra. Now, so that essentially completes the lesson. We're going to use pi algebra all the time when we graph trigonometric functions. So I hope this important video has set the stage for your success in videos 2, 3, 4, and 5. Thank you for watching.